Hello students, today let us learn a few more exceptions of metals and non-metals. Coming to lithium, sodium and potassium. See, when we look at their atomic number, lithium is having atomic number 3 and electronic configuration 1s to 2s1. Sodium, atomic number 11, 1s2, 2s2, 2p6, 3s1. Potassium, K, atomic number 19, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So now let us just concentrate on the outer electron, sorry, valence shell. Okay, now the valence shell is 2s1, 3s1, 4s1 respectively for lithium, sodium and potassium. Now because of this nature, okay, now and the atomic structure, so now when we look at the atomic structure, we all know that the atom is having a nucleus and it is primarily made up of proton and neutron, and there are electrons which are revolving in specific orbits around the nucleus. Now when we talk about these metals, lithium, sodium, potassium, they're having one electron each in their outermost orbit. Now because of this arrangement of electrons in atom, they have a special feature, okay, or a different characteristics. That is, all these three metals are soft metals. Means we all know that metals are very rigid and they're very strong, so they cannot just be deformed by just touching or hitting them, right? We need immense energy and strength to deform any metal, piece of metal. But because of this nature of the atom, atomic structure for these three elements, that is lithium, sodium, potassium, they tend to be called as soft metals. Means they can easily be cut with a knife. Okay, these are very soft metals. They can be easily cut using a knife. And one more thing is these are very reactive and they're highly exothermic. So when you just place, we all have also observed in our chemistry lab that sodium is usually stored under kerosene. And why it is not stored in water, or why is it not stored in any other organic or inorganic solution, is only because sodium is very, very reactive. Okay, they are highly reactive, and this makes it also a good explosive material. So when you just place it on a slab or on a table, they can easily explode and they can cause damage. Okay, so that's the reason why they are stored in kerosene. And also when you observe the reaction of sodium with water also, they're highly explosive, and they produce a lot of hydrogen gas. And when they produce this hydrogen gas, this gas is sufficient to catch fire. Okay, the entire surface of the entire surface of the beaker or any container in which you have kept sodium in water will easily catch fire. So that is why sodium or lithium or potassium is stored under kerosene and not under water. Okay, so these are some of the exceptions wherein these three elements become soft metals. Now, next, one more exception would be with carbon. See, we all know that usually non-metals are brittle, and they are so the moment we use the word brittle, it means that they're not strong or they're not hard. They're very soft. But there's an exception, that is allotrope of carbon. So what is meant by allotrope? These are compounds which exist in different physical form. Okay, so they're primarily made up of carbon itself, but their structural arrangement makes them different from other non-metals. So when you observe allotropes of carbon, some of them graphite, diamond, fullerene, charcoal. Okay, these are some of the allotropes of carbon. Now when we look at diamond, so diamond is having tetrahedral structure. Means we all know carbon valency is 4, right? So diamond, students, it is each lattice, okay, or each unit of diamond is like this tetrahedral. So because of this tetrahedral, just imagine tetrahedral just sagged one against the other, one above the other and below the other. So the entire diamond structure will look something like, all these tetrahedral structures of carbon fused. So because of this three-dimensional structure, diamond becomes one of the hardest substance. So we know that diamond is primarily made up of carbon, and carbon being non-metal, we should have thought that non-metals are not strong and they're brittle. But because of this three-dimensional nature of diamond, that is a tetrahedral form, tetrahedral structure, makes diamond one of the hardest materials. So we all know diamond jewelry, or when it comes to welding and also when it comes to cutting metals, diamond is used. So it's so fabulous nature of diamond. Similarly, graphite. See, graphite is again talking about conductivity in non-metals, impossible, because non-metals do not have any uh, extra electron for conduction of electricity or heat, right? But graphite is one of the example for non-metal which conducts electricity. See, most of the um, separation or decomposition reactions which involve graphite rod, okay, um, there we make use of graphite. Though graphite is non-metal, why we are making use of graphite as an electrode? Because graphite conducts electricity. So how, let us understand. See, observe the structure on the left side on your screen. This is the uh, graphite three-dimensional structure. So how is the graphite structure? So it is hexagonal. Okay, hexagonal means at each point there are carbon, and below this you can expect one more hexagonal. So here the top layer is one hexagonal, the bottom layer is one hexagonal. So like this, students, it is it can slide over one another. Okay, so you can just imagine you have kept a pile of books and you want to pull the bottommost books. What happens is the remaining books above it will just slide over one another. So can you imagine? So just that way we can expect graphite to exist. Okay, because of this nature, okay, sliding nature um, of carbon atoms makes graphite very very um, soft and durable. And one more reason why it is a good conductor is because we all know for conduction of heat and electricity there should be free electron. So that free electron is present in graphite. So that's the reason why graphite is used as conduction, or sorry, used as electrode in electrolysis of water, or even otherwise in metallurgy. Graphite is used in the form of graphite rods. So let me just explain to you the reason of conduction. So we all know the atomic number of carbon is 6 and configuration 1s to 2s to 2p2. So when we try to write the distribution of electrons, okay, so this is 1s, 2s, and this is 2p. And we all know that 2p is having p orbital has three um, suborbitals, px, py, and pz. Okay, so this is the ground state. So when the electrons have not absorbed energy. Now let's imagine there's some radiation being absorbed by the carbon atom and they get excited. So when the electrons get excited, what happens is one of the electron from 2s will jump to 2p. So now how many electrons are there here? Now there are four unpaired electrons. And we, basic knowledge of bonding, we know that every time a chemical bond is formed there must and should be minimum of two electrons for a bond to be formed. And these are all unpaired, means they are looking for another electron to get bonded. Okay, so now here what is the strategy here is that for graphite one of the electron is reserved. So just like how we save our money in bank for a future use, right? Just like that, one of the electron of 2p orbital gets reserved. Now the remaining three will form bond with carbon atom. Okay, now this extra electron is nothing but the electron which is moving around in this lattice. So as I already told you, this is the hexagonal structure of graphite, and this one electron, students, will be moving around in between the orbital. Now, this is why graphite becomes a good conductor of electricity. And the basic understanding for how a metal can conduct electricity is only because of free electron. So, electron must continuously move. Like when we talk about the switches in our home or any electrical appliance that we are using every day, is only possible because there are electrons moving through the wire. And copper, we know, aluminum, we know, iron, we know, they are the best conductors of electricity because they can easily transport the electrons from one part of the home to another part. So, but this work is being done by graphite. Okay, so please this understand these are the exception. One exception is that diamond, though being non-metal, is hardest one of the hardest substance in the on the planet. Similarly, graphite, being non-metal again and an allotrope of carbon, but yet it conducts electricity because of free electron. Okay, so this is all for today's class. Please subscribe my channel and share my channel. Thank you very much.